We're gonna start like 10:08, 10:05. We do a small, like a quick introductions of you. Then we hand it right to you. Usually the sharing is around 45 minutes if it's not hands-on. Then we do have a Q&A. We use Slido for Q&A. So at the end of your talk, we show you the Q&A in Slido. Of course, you don't have to answer all of them. It's really up to you how long the Q&A sessions going to be. Just let us know if, hey, I think this is going to be my last questions or whatever the case may be. If you have to attend to something else, just let us know. Yeah, pretty much that's it. Do you have any questions?
No. So it's going to be a 45-minute talk, right?
Around 45 minutes. Of course, it's not like a strict set in stone. Like you can, of course, always less or a little bit above. It's okay. But by default, usually our sessions around 45 minutes to an hour for the sharing.
Right.
Around that time, like you don't really have to go strict 45 minutes and then just do whatever you have prepared. Do you want to try share your screen?
Yeah, sure.
Yeah.
By the way, Laura is here.
Hey, Laura.
Joining.
Morning, Laura.
I will try to make her as a co-host.
Jason Mays.
Yep. The slides are actually made by this guy.
Okay. Yes, looks good. Do you want to try to play it, Imran? Yeah. Do you have any video with the somebody is actually taking a measurement of my window, so I'm gonna use the mask for a bit. Do you have a video with the slides?
The video?
Yeah. Do you have any video? Because if you have any video, I think in the beginning when you start sharing, you need to include the sound on the bottom left corner. Laura, hey Laura, have you updated the YouTube link?
The YouTube link. I think I have to wait for Rika to share me the newest link, and then I'll update it there.
Oh, sure. I think we're going to broadcast it at 10. Yeah.
Awesome. All right. Good to see Imran is here already. Thank you, Imran, and good morning.
Laura.
Do you have any video that on the slides, Imran?
Yeah, no, I don't have any video.
Oh, okay. So this is fine then. Okay.
Yeah.
Hey, Laura, check the WhatsApp, please. My Erika just sent you the URL. Oh yeah, you got it. Okay.
Yes.
Do you mind if we sure?
Yeah.
Imran, do you mind if we share if we take back the screen because we have a welcoming slides?
Yeah, sure. Okay.
I'm gonna step out and check on YouTube. All the best, and if you need me, ping me on WhatsApp.
Sure.
Thank you, everyone.
Thank you, Laura. Selamat pagi teman-teman. Thank you sudah join ya. Hari ini kita masih di Tensorflow everywhere with Google. So we have a very special guest today. We have Imran Salam from Pakistan. He's currently living in Pakistan, who graciously enough setting aside his time to share knowledge with us. So we're just gonna wait for another 5 minutes for people to join in. We're also live on YouTube. We're also broadcasting this on YouTube. So please let your friends know. Broadcast it in your social media also. We have a YouTube, Google Developer Jakarta channel. Okay, see you guys in 5 minutes. Hello, good morning, everybody. Thank you again for coming this morning to learn together and to listen to one of our mentor, Imran. So thank you again, Imran, for setting aside time to share your knowledge with us in the Jakarta Machine Learning community. Also, big thank you for Google of course, and for TensorFlow Everywhere for organizing this whole event. Of course, Laura also, thank you. So without a further ado, I'll give the time and space to Imran.
Hey everyone. Thanks Ricky for the introduction. So I'm just gonna share my screen now, and we're going to go ahead with the presentation, right? Okay. So again, thanks for the introduction, Ricky. And since these slides are made by Jason Mays, the senior data analyst transfer Jis. Unfortunately, today it's not going to be him, but me who's going to present the slides and tell you more about Tensorflow.js. A little short introduction about me. I'm a Google developer expert in machine learning and also a senior machine learning engineer at Red Bull, Pakistan. And I also live in Pakistan as well. And I think this is my first talk outside of Pakistan, so it's also a new experience for me. So I'm really hoping this goes well. All right. Uh, Thank you. So let's start. All right. So today's our topic going to be superpowers with TensorFlow.js. So we're going to study in detail what are the aspects of TensorFlow.js, how we can use them, and why is it why is it useful for us, right? And again, these slides are made by Jason Mays, senior data analyst at TensorFlow.js. All right, machine learning in JavaScript. Why? Like, why do we need machine learning in JavaScript? We have machine learning in Python, we have in R, we have in Julia, we have in lots of languages. Why in JavaScript? Why do we need machine learning? There are a couple of answers for that, right? Let's find out. One particular answer is you can basically run JavaScript anywhere, right? Right now you're using it on your browsers. It can be used on your servers, your desktop apps, your mobiles, and your IoTs. And now we're going to see how exactly we are going to use them in all of these different platforms, right? So we do know that on browsers uh, we have browsers like Chrome, Firefox, Safari, right? And they all use JavaScript, right? Now on the server end, we know that there's a backend there's a backend JavaScript as well, which is called Node, right? Node.js, and since it's also written in JavaScript, we can use our TensorFlow.js model on server side as well, and that way we can actually use the power of GPU. And on your mobile, you have your React Native. React Native uh, uh, is a pla- uh, is a what do you call it? Is a language where you can write code for your mobile apps. It works for both iOS and Android. You can use TensorFlow.js there, and then you have Electron. Electron is basically a desktop application where you can code in JavaScript as well. So you're making a desktop app, but you're coding in JavaScript. So you can import your TensorFlow there as well. And of course, in IoTs, you have Raspberry Pis, and in Raspberry Pi, you can use your JavaScript by using uh, uh, a language like Node.js, right? Which is also again a server backend language. All right. So there are three aspects of TensorFlow.js, right? And this just does not go for TensorFlow.js. It goes for most of the deep learning. Right? So the first aspect is run an existing model, run an inference or test your model, right? So what happens is that you have a model uh, that you've trained. It doesn't matter on which language or which platform you train, right? You have that model, and then you run some examples or you run some samples through that model, right? right? You infer your examples through that model, uh, and yeah, that's it. So you have so this is the first aspect, right? You run some examples, you run some inferences on your model, right? The second aspect is retrain your existing models, right? So for example, you have a model that you've ported from Python, or what you can do is you can port that model into Tensorflow.js and then retrain that existing model with new data, or however you like, with new hyperparameters per se. You want to retrain that model, right? You can do that. And apart from all this, you can write your own model in JavaScript, right? You can write your entire model in TensorFlow.js. Like you can train from scratch as well. So so this is like complete framework for a deep learning, like it's a complete deep learning framework that they've provided for you in JavaScript, which is essentially I think the first major deep learning framework for JavaScript, major deep learning framework, I must say. And then again, there are some useful applications as well, and now we're going to see them see most of them in detail right now. But here we have listed some of the few very basic and very useful examples of aspects of machine learning that we've actually written and coded in JavaScript, and we actually have a live demo as well for each of them, and we're going to show you how they work, right? So let's say, so see, you have the augmented reality, you have the gesture-based interactions where you can assign different classes to your gestures, and then on runtime, on the inference time, you just give a gesture, and it's going to predict you the correct the correct class for your particular gesture, right? You can use it for sound recognition, accessible web apps, sentiment analysis, abuse detection, basically the NLP, and conversational AI, basically an AI that actually makes a conversation with you, and for the search engine optimization as well. So basically, anything you can run on your browser, right? Anything you can run on your browser, either it's client end, or either it's a server end. You can do that with TensorFlow.js, right? Because it's basically running in your browser. Like that's a remarkable thing, right? So let's look at some more examples. Let's look at some more fun things we can do with TensorFlow.js, and hopefully we have a demo for them, right? All right. So this is one very important aspect that we've already talked about is pre-trained models, right? Uh, so what TensorFlow.js has provided for us is that pre they've trained a lot of machine learning models, right? And these models are not on just not only the classification models, right? They're object detection models, they're word segmentation models, there are all sorts of models for text classification. They've trained those models, and they've put it on their TensorFlow models uh, page, so from where you can download them, right? And they're also expanding their collection. As you can see, they've added three extra models: the face mesh, hand pose, and the bird Q&A. You can see that it's bird, so it's relatively newer, right? So the community keeps on adding new stuff uh, to the old models collection, right? So if we look here, we have a couple of models that TensorFlow.js already provides, and you can fine tune these models. In fact, a, a few of them is like image classification, object detection, port segmentation, pose estimation. Uh, so basically, the first row is I think computer vision models. Second row is essentially the NLP models where you classify the text toxicity. Uh, Either your text has negative emotions, positive emotions, or neutral emotions, stuff like that. You can sentence encoding, and then speech commands, and then there's a canon classifier is there as well. So the main gist is the TensorFlow just provides a lot of already pre-trained models for you, right, to make your job a lot easier. Like here's an example of an object recognition using Coco single shot detector. Coco is basically a dataset. SSD is an end-to-end machine learning object detection model, and it's trained on 90 object classes, right? There's no point in. Okay, check. Let's try to see the demo, right? Let's see how it works. I'm going to enable webcam, and okay, it's detecting me a person with 89% confidence, and it's running in your browser, right? So that's the yeah. Okay, let's see if it detects Pinocchio or not. No. All right. So you see that it's basically running in your browser, and it's real time. So that's a major accomplishment. Right. And JavaScript can do that. Oh, and then there's this another great demo for uh, another aspect. It's called face mesh. So basically, it detects landmarks on your face, and currently it detects 468 landmarks, and it's also used in face recognition as well. Let's try its demo as well. Again, it's written in JavaScript, so and it's going to take a lot of time. Oh, actually, it rendered quite quickly, right? It's real time. All right. So here we can see two machine learning, computer vision use cases. One of them is is a is a body segmentation part, and the other of them is pose estimation, right? So you're also estimating the pose, and there's a model that's doing both of these models are doing both of them. You can see they're also in real time. And then again, there is no limit to your creativity. You can go above and beyond your like you can go wherever your imagination will lead to you, and TensorFlow.js is going to help you a lot, believe me, since it's almost real time in browser, uh, all very quick to learn, very quick to import, and you know start doing it. And since TensorFlow.js also provides a lot of pre-trained models as well, so it's going to be really easy to play with your creativity a little bit. Okay, so here's a fun application, right? It's called invisibility. Basically, what's happening is that a person is coming into the room, but on one screen we see him, the input screen, but on the output screen we do not see him. So we've actually, uh, yeah, we erased the person from the room. So does anyone know what technique it's called? sorry. So this particular technique is called in painting, right? So what's happening is that uh, so there are two parts of this technique, right? First part is segmenting the body of a person at each frame. Now, once you detect or segment the body of the person in each frame, right? You can drop those frames. Now, how will you fill those frames with the background, right? Now, this problem is called in painting. In painting is a problem where you try to fill some pixels with the surrounding using the surrounding pixels and try to make a sense of it. It's a machine learning. It used to be an image processing problem, but now it's a computer vision deep learning problem, and deep learning frameworks are there to solve it for you, right? It's a fun application as well, and this again is also coded in TensorFlow.js. Okay, here's a cool app. So as you can see, there's this guy, and lasers are coming out of his eyes or his mouth when he opens it. Uh, Again, this all of it is written in JavaScript, um, and using TensorFlow.js and WebGL shaders. WebGL is a graphic library for web, and it's using its shaders. Shaders used for shading technology. Uh, the code is given as well. Although I don't think it's very readable here, but I think you can find it on open source. You just have to search WebGL shaders plus TensorFlow.js, and you're going to find it. In fact, there's given a reference for the but about the guy who made it. So you can just Google it and you will have the code as well. So it's a good cool application, right? See, there are a bunch of cool applications in TensorFlow.js. Okay, here's another cool one. It's called teleportation, right? So what's happening is that you take you take a video of a person, right, doing anything, for example, dancing. You segment the person uh, for each frame. You segment him, and then for the output, you take another video, and then you put that person in the middle of the video, or in the middle of each frame of that video, right? And you have a very neat and clean cropped person uh, under that in each frame, right? So that's another cool application, right? Yeah, and it's basically written in WebRTC, the real-time communication framework, and the augmented reality frame of it's augmented reality framework. It's also open source uh, and TensorFlow.js, right? So it's a teleportation app, and I think the code's available open source. You can check it out. It's really cool. I'm gonna check it out as well, man. Yeah. Okay, so here's one of the applications that I really love, and I think is very useful in e-commerce apps and other clothing apps. So what you do is you just give them your height in centimeters, right? And it's going to calculate the size of your clothing. Uh, so you don't have to uh, you don't have to let's say you don't have to write it on your own, like either it's medium, large, it's extra large. Sometimes we get it wrong, sometimes we get it right. So this computer vision app is going to do it for you. It's going to just only take your height in centimeters and compute compute your let's say your fittings, and then it's going to tell the uh, tell the backend that this is your particular size and that is your accurate particular size, right? And it's such a useful application. There's another cool application made under WebXR and Web Graphics Library with Tensorflow.js. So you take a picture, you make a mosaic of it, and use all the powers of WebGL and WebXR to to do this sort of animation with it. That's really cool. That's really okay. Another very big aspect of machine learning is called transfer learning. Uh, if you're from the field of machine learning, you already know that most of the time you're only just fine tuning or you're doing transfer learning with your model, right? You retrain your existing models with your own data, and largely a part of it is because usually the pre-trained models are trained on very big data sets, and you would actually want to use those features as well, so you use transfer learning. uh, yeah, I mean, you can do that in TensorFlow.js just like you can do it in Python, and there's actually no difference, and we're going to see how we can do this in TensorFlow.js. So here's a very cool application that actually I'm going to demo you because I saw that slide and I think it's really confusing here, so I'm going to go to the demo. Okay. uh, I'm going to do an image project, right? I'm going to add the class one. Let's call this class face. So I'm going to record myself, right? I have the 87 samples that I've generated right now, right? And now for class two, I call it hand, right? I'm going to record my hand. Oh, sorry, I did not record it. Okay, so I have made data set of with two classes. Now let's train the model. So with just one click, and in real time, we're training the model as well. Yeah, let's wait for it to train. It's going to take a very few seconds. So it will train for 50 epochs, and since the data set is very small, it's going to train very fast, and in just a few seconds, the model will be available for us. All right, model is trained. So see, real time, it's detecting my face. Now it's detecting my hand. Right? Face, hand, face, hand, face, hand. See, it's all happening in real time. I really like this application. It really shows you the power of machine learning in web, right? Okay, so AutoML is basically what you call an end-to-end machine learning. So where you just have to provide the data and your goal, and the AutoML is going to figure out everything in between and just give you an end-to-end use case. So what you can do is you can train your models in the cloud using AutoML custom vision. For example, there is an example of a custom vision model. You can train your vision models in the cloud and then deploy them to TensorFlow.js, right? You export your models, you import that exported model in your JavaScript with TensorFlow, and then you can use that model. Let's and there's code available for it, right? But let's find out how it works, right? Okay, so here's the thing. So you define your model, you optimize your model for either of these three things, and then when your model is trained, you're given some choices to export your model to. Uh, you, for example, first select TensorFlow.js, you export your model on TensorFlow.js, right? And this is how you're going to import that model. Now, in the first two lines, you're only importing the TensorFlow.js, TensorFlow.js. In the third and fourth line, you're actually just getting an you're basically just getting an image, right? And the image is on the Google storage, and then there's a script. There's an asynchronous function, right? And in that function, the first line is load image classification df.automl.load image classification, where you're loading a model, right? You're loading a model that you just trained on cloud custom vision, right? You load that you loaded that model as a model.json, right? Then you get an image from the image ID that we've just defined before, and you and the predictions on the predictions line, what you do is that you just run the inference of that model using the image. That's it, and you run the script at the end. So that's it. That's basically how you run a simple custom vision model on your TensorFlow.js. That's how you port it. That's easy, very easy. You could write your own code, superpowers and performances, and like I said, creativity, it's infinite. Uh, make new stuff with it, and with client side TensorFlow, you can do wonders with it. Believe me. Okay, just like Python, TensorFlow.js also has higher level and lower level APIs, APIs and the high level layers APIs, just like in Keras.layers. Remember that? And so we have that layers API as well. On the right side, you can see these layers, different sort of normalization layers, convolutional layers, and basic layers. Okay, so this is the base structure. On the lower end, we have the core API, on which you can create your own custom models or custom layers as well. And then you have the layers API. It's just like the Keras API, where you can define your layers. For example, you want to use a dense layer, a convolutional layer, and you want to stack them together, you can do that in the layers API. And then you have the models API. You have the pre-trained models. You can just import those models, run the inferences through those models, and just be done with it. If you don't want to add or spice things up a little, right? And you can run these things, you can run the core layers or models on your client end, which is basically your browser, using either JavaScript, React Native, or, and you can use the CPU and the web graphics library, right? And you can also do this on the server end using Node.js, and there, in fact, you can actually use the GPU as well. And again, the layers API is just like Keras model, TensorFlow. Oh, and the core API can also use the TensorFlow safe models, right? And there's a TFGS converter in the TensorFlow.js. Okay, here's a fun. Now let's go to the fun part, right? The performance timings, right? Oh, so the normal TensorFlow CUDA 1080 GTX takes around, say, if 10 milliseconds, oh, 7. It takes around 7.98 milliseconds, and TensorFlow.js on Node using CUDA takes 8.81 milliseconds. Not that much of a difference. And with TensorFlow on CPU with AVX enabled takes 20.5 milliseconds, and TensorFlow.js uh, Node CPU with AVX enabled takes 23.1. So you can see there's not much of a significant difference. And you can also take benefit of the just-in-time compiler of Java when you're running it on Node as well. And here's a very fun thing, right? So we have a Hugging Face digital bird. Uh, Using Node.js, we can see that we have a 2 times performance bonus, right? So basically the more this bar goes horizontally to the right side, it's bad, right? It's more time. We need less time, right? So we can see that the safe for model, the question answer model on Node.js takes a particularly lesser time than it takes on Python, the real TensorFlow. Okay, so 5 client-side superpowers. So there are uh, five useful ways you can take the power of TensorFlow.js on client end. The first part is privacy, of course, because you're running it on your own browser, and the internet cannot access it unless you allow it to, right? Lower latency, of course, because it's on your own browsers. It's running right on your own machine. A lower cost and interactivity is one of the most major reasons you use it on client. You can make it very interactive. You can make it learn on the go, and then you can scale it as well. And there's GPU support using WebGL. Okay. On the server end, you can use basically the very main aspect, or the most important use case is you can use the safe models without conversions, right? You can use the TensorFlow Python TensorFlow safe models without converting them without using without using the TFGS converter. You can just use them in Node.js as well, right? As it is. And you can just you have code in just one language. If you already use JavaScript, you can just code in it, and you can use the just-in-time compiler of Java to boost your pre or post processing. Again, TensorFlow.js has a relatively big community, and you can learn more and get inspired using these links. So, for example, for some basic learning, you just have to go to a website, tensorflow.org/js. And if you want to download the pre-trained models, tensorflow.org/js/models. And there's GitHub code. There's a Google group called TFGS at tensorflow.org. And then there's CodePen, there's Glitch. We can, oh, and One important thing is there's a recommended reading. It's called Deep Learning with JavaScript, and it's a relatively easier book. It starts considering you're a beginner and takes you to an advanced level. Uh, I think it's the I would definitely recommend reading this book and join the community. And again, make it TFJS. Let's see what will you mix. See, there's another application. Although I'm not sure of what application is that actually. I think it's in painting, but not done right. But then again, in painting is a relatively hard problem. So I don't blame the guy. Anyways, stay in touch. The slides are made by Jason Mays. Again, I'm not Jason Mays. My name is Imran Salam, and I'll be open to your questions now. All right. Thank you. Okay, I'm going to open the chat.
Thank you, Imran. Thank you for the presentations.
Thank you.
So, guys, do you have any questions? Check the Slido. Nobody asked yet. Or maybe if you want to ask in Indonesia, it's okay. I can translate it too. Just open up your mic. Anybody want to ask something?
Hello.
Yeah.
Hello, my name Ahmad. I want to ask how to transform model in JS to APK. I mean in Android platform. How?
I'm sorry. Can you repeat that? S2 APK?
Yeah, I think the question is how to transform from JavaScript to APK. Is that right, Mas Ahmad?
Correct.
For Android.
Okay, so Android has a TensorFlow Lite, right? You can run your the TensorFlow models using TensorFlow Lite. First, you have to convert these models into TensorFlow Lite, and mind it, there are some issues with conversion because TensorFlow Lite does not support all of the layers. Uh, so if your model has the layers that are supported by TensorFlow Lite, what you do is you convert your TensorFlow.js model into TensorFlow Lite model, and then you can port it into S2 APKs, right?
Does that answer your questions, Mas Ahmad?
Okay, thank you.
Yeah. Okay. Anybody else? Anybody have any other questions for Imran? Boleh pakai bahasa Indonesia, boleh. Nanti saya translate. Mas Suardiantara, dibuka aja Mas, mic-nya Mas.
Okay, Mas Ricky, thank you for the
Yuk.
opportunity. Hello, Mas Imran. I have a question. We have TensorFlow in Python, and we can use it as server side too. If we make an API to process or to do some task, what is the difference with the one which is made by Node.js? I mean, what is the significant or the use case when to use the TensorFlow with JS and Python? Because we can do both in server side.
Yeah, actually, that's a good question. As you can see that I have shown you a use case where I've used TensorFlow.js using Node.js on the server end, right? You can do that in Python as well, right? But the problem is, I've actually written it here. Most of the what do you say? The code is written in JavaScript already. It's already written in Node.js, so you don't have to add another language or another dependency on your system. All you have to do is write that code in Node.js as well, because we know that most of our backend applications, the web applications, are already written in Node.js, right? And I've added a consensus here. It says 67.8% of people use JavaScript in development already, right? So instead of just switching to another language just because you have a machine learning model in it, you can just use your uh, your daily Node.js for your machine learning tasks as well. So it's just a matter of what you use. Instead of adding another language to your system, you can use it using your previous language. And given that that language is used by most of the developers.
Sorry, Mas. So the main reason is the learning curve, right?
Uh, Mm, actually, that depends, right? If you're coming from a Python background, Node.js or sorry, the JavaScript has a learning curve. If you're coming from a JavaScript background, Python, it also has a learning curve. So basically, it depends, right? If you're a web developer and you're trying to switch to machine learning, you're gonna have to essentially learn Python. You can just do that in JavaScript as well.
Okay, Mas. I think there is some technical reasons to when to use Python-based models and Node.js or TensorFlow.js based model.
Mhm. I'm sorry, I could not
So I
understand.
think his question is more like, do you when you decide, right, Imran, when you decide, oh, I'm going to use Node.js, or when I'm going to use TensorFlow.js, is there a specific technical or requirement that you have to do it in
Yeah,
those,
actually,
right?
there's no technical requirement.
Okay,
It just depends on your application or on your on your choice per se.
right,
So, for
right,
example, your entire system is written, or your web system is written in Node.js, right?
right.
And you don't want another language to just to port machine learning. So what you're going to do is that you're going to only use the Node.js for machine learning with TensorFlow.js.
Okay. So pretty much what you can do in TensorFlow.js, you can do also in Node.js with Python, correct?
No. In Node.js using Node.js. So Node.js also uses Node.js.
Hello, hello.
Hello, yeah.
Yeah, yeah. Itu tadi ya pertanyaannya ya, Mas Suwardiantara.
Iya, Mas.
Oke.
It's just beda alasannya kenapa sih kita
Ah,
pakai TensorFlow.js dan Node.js
right.
dibanding dengan Python selain alasan language preference ya.
Yeah. Right. So for now, Imran, there's no specific technical reason for you to use one or the other, right? It's just a preference on that moment, right? Maybe if you say, oh, I think I can do it fast, maybe, or just more into a personal reason. If you say, oh, I think this is going to be a faster with
More personal.
Node.js, or this is going to be a faster with
Yeah,
uh, TensorFlow, correct?
yeah.
Okay, cool. Hope that answers ya, Mas Wardiantara.
Thank you, Mas.
We actually have two questions in the Slido, Imran. Let me translate the first one, yeah? Do we need to do data pre-processing, data cleaning with TensorFlow.js? If we do, how do we do it?
So just like in TensorFlow, you have a lot of uh, pre-processing or post-processing tools in TensorFlow.js available as well. You can do those in TensorFlow.js, and you might also notice that in Python we also use NumPy and some other vectorized libraries. We have those. We have these sort of libraries in JavaScript as well. use the power of those libraries, and then combined with the pre-processing and post-processing of TensorFlow.js, we have a pretty toolkit for our pre-processing and data clean.
Okay, cool. So the second one is TensorFlow.
Oh, it's in
Oh,
English.
it's in English.
TensorFlow.js is basically connects Python and JavaScript. Actually, no, it does not connect Python and JavaScript. TensorFlow.js is a very different thing than simple TensorFlow. It's written in JavaScript and use just-in-time compiler of Java. The step is finish the model first, then build the JavaScript code, or it must be built together. Finish the model first.
Imran, can you actually talk a little bit closer to the mic? I think your voice is kind of in and out.
Sorry. Okay. Um, TensorFlow.js is basically connects Python and JavaScript. No, it does not connect Python and JavaScript. Basically, TensorFlow and TensorFlow.js are completely different things. The TensorFlow for Python is different, and TensorFlow.js is different. Although you can export your models from one to another, and the step is finish the model first, then build the JavaScript code. No, basically you can build your model. You can run. You basically, when you're building your model, you're actually coding it, right? You're coding it in JavaScript using the TensorFlow.js framework. So yeah, so,
I see.
uh,
Okay.
yeah.
Okay. Cool. Anybody want ask anything else? You can just open your mic. Nobody? Okay. Again, thank you so much, Imran, for sharing with us today, this morning. It's really early in the morning in Pakistan, right?
Yeah.
Again, thank you, Google. Thank you, TensorFlow Everywhere event for collaborating with Jakarta Machine Learning. Also, thank you, Laura, for organizing this whole event. Oh, there's one more question. So in conclusion, for someone who never learned JavaScript but usually codes with Python, it wouldn't be a problem, right, to build a model in Python?
I'm sorry, I did not get it.
Okay, let me share again.
Can you please
Let
share?
me share my screen again. You see it?
Yeah. So in conclusion, for someone who never learned JavaScript but usually uses Python, it won't be a problem, right? To build a model in Python. Yeah, no, it won't be a problem.
Sure. No, another one. The FJS could be retrained and create model. Is it possible? The training, not the fine tuning. Is it possible to train transformer like BERT in TensorFlow.js?
Yes, you can do that.
Yes, you could train
Yeah.
transformer in TensorFlow.js. Anybody else? There you go. How
Satu
about
lagi, Mas.
our TensorFlow bootcamp? When can we start this program? Yes, we're still in conversations with Google and Laura because it takes quite preparation. Yeah? Like we mentioned before, we want to have a more maybe semi bootcamp, not like everyday bootcamp, maybe like twice a week or even once a week. But we wanted to be a little bit more responsible in terms of all the people that they're going to the bootcamp. We hopefully could be a GDE from Indonesia, especially for machine learning. So still looking at we're still looking on a lot of stuff like when the event going to be, how we're gonna run it, who's going to be the speakers, who's going to share knowledge, what kind of assignment, right? So there's a there's a lot of aspects to think to kind of consider, but hopefully we could hopefully we have an update within a month or two. But we maybe, to be realistically, the program itself hopefully gonna run after it, after Lebaran. Because if we're gonna run like 2 months or 3 month program in the month of April and May, then I think it's not a good idea, because we run like 2 weeks or 3 weeks, then we gotta cut off with Lebaran. So maybe we're gonna plan it. We're gonna do everything's okay. By the April or May, we can start doing the intake, but the program itself probably most likely going to be after Lebaran. Mbak Ade or Mbak Erika, maybe you have something to add for the bootcamp?
Just keep in touch.
Just follow our social media, LinkedIn, Instagram, website. So everything's going to be posted there. But no, don't worry, we're still working on it. If I have a link,
There's no question there.
sorry.
You-
Your voice is breaking out. Okay. In the meanwhile, Imran, I think the other question is for you. If I have a limited amount of data set, how can I do with TensorFlow to deal with this problem?
So it depends. If you have a pre-trained model that is already trained on a larger data set, you can just fine tune your model, and
Sorry,
that's how you do it.
sorry, Imran, your voice is kind of in and out again.
Okay, so when you have a very limited data set, what you do is you basically try to fine tune your model using a pre-trained fine tune your pre-trained model, right? You use a pre-trained model instead of training from scratch.
But I guess, to be fair, if we have a limited amount of data set, that's going to be a problem regardless of what framework or whatever you use, right?
Yeah, the least you can do is use a pre-trained model.
So maybe the question was, could we use the same method? Like, let's say you have a limited data set or unbalanced data set. Can we use the common known method in TensorFlow also, or there's a specific requirement to do it in TensorFlow?
You can do that in Tensorflow.js as well. Yeah.
Same thing, right?
Yeah, same thing. Exactly same.
Okay. Ada lagi yang mau nanya, teman-teman?
Mas izin bertanya lagi.
Boleh dong.
Mas Imran, I have a question. In
Sure.
front-end development, we are facing a phenomenon where so many libraries needed to import to our project.
Keputus mas tadi, mas, sorry mas. So many what?
So many libraries needed to import it to our front-end development project. So the build app of the size will be increasing, and then if we use TensorFlow into our project, it will be increasing. I think 3 megabytes for one model or one library is quite large for to be imported to our front end. How to deal with this mass?
So basically, that is a problem, right? And there's no workaround for that. If you have to import it, you have to import it. You can get away with that. Yeah.
Yeah.
I mean, by is it okay to build an API? I know that TensorFlow has provided so many API, but to tackle the problem of big size of the front end apps, which is in client side, is it okay to I think made some modification to make the API more specific or something like that?
I'm really sorry. I actually did not understand it.
Mau bahasa Indonesia aja nggak mas? Saya coba translate mas.
Jadi
Pertanyaan.
maksudnya kan kalau di front end itu terlalu banyak library yang udah keperluannya untuk tampilan gitu mas.
Ya.
Nah untuk melakukan ini task yang berat ini bisa nggak kita untuk bikin API yang lebih khusus lagi di server side-nya gitu. Jadi nggak membebani size si aplikasi front end.
Oh, okay. So Imran, for front end purposes, right? The front end application itself is already have a lot of libraries, right?
Yeah.
So is there any way we can create separate APIs to train or to train ya mas ya maksudnya ya?
Import modelnya.
Or to import the models to the front end. So instead of just, I think so you want to do a regular JavaScript for actually front end and create another API ya mas maksudnya ya?
Ya betul. Jadi
For the model.
ya betul.
So you have two APIs, right? One API is for actually the developer, the front end developer, right? To the apps, and another API just for the model from Tensorflow.js. Is that something that possible?
That is possible. Yeah.
Do you understand the questions?
Yeah. I
Okay. Yeah. Hello. Hello.
Oh.
Hello. Hello, Imran. Can you hear me?
Yes, I can hear you.
Oh, okay. Yeah. Do you have anything to add to that? Is it possible, or do you aware of that?
Yes, sir. Yes, it is possible. You can do that, but I've never seen anyone do that. But yes, it is possible.
Okay. I mean, I think this is only my 2 cents, yeah, mas. If you run it into a containerized services as a microservices, I think that's really possible, correct, mas?
Yeah.
Tadi yang nanya, sorry, mas siapa ya? Mas. Halo, mas.
Iya mas, sudah terjawab.
Iya, kayaknya kalau menurut saya itu kalau di running sebagai microservices dan di Docker ya di containerize itu shouldn't be a problem gak sih?
Iya maksudnya lebih baik kan mereka sudah sediakan untuk langsung dipanggil di sisi front end. Maksudnya ada nggak concernnya untuk kan udah dibikin di front end ngapain lagi kita rewrite or modify di API untuk ditaruh di server. Maksudnya mau minta persepsinya dia gitu.
Oh, kayaknya dia juga nggak tahu deh, dia nggak pernah lihat juga kayaknya dia bilang.
Iya mas, dia udah bilang tadi.
Okay, that's a good questions. Let's all search together and come back to it. One more questions, Imran.
Okay.
Could the TensorFlow.js solve special data problem like datasets for predictions with maps?
Prediction with what actually? I'm not sure.
Again, we haven't seen it yet. What's the concern ya? Maybe yang nanya ini, what's the concern that maksudnya kenapa why do you think it's not possible? Yeah. So I guess for this we haven't seen it either. Imran haven't seen it either. So there's 2 questions that we have to research together. Oke. Ada lagi nggak teman-teman? Kira-kira. Betul-betul ya. Ada yang mau nanya lagi langsung dari Mike? Okay, semoga. Okay, again, thank you Imran, thank you Google, thank you Laura, Tensorflow everywhere. Thank you teman-teman udah datang pagi-pagi spend time sama kita, belajar bareng. Minggu depan, we still have another session of Tensorflow everywhere. It's going to be with Mas Dita from Gojek. It's going to be about TensorFlow in the TensorFlow model in Edge, in devices. So please stay tuned. Kasih tahu teman-teman yang lain, join the event. It's going to be great. Dari saya udah, Mbak Erika atau Mbak Ade ada pengumuman nggak ya?
Nggak ada. Ayo kita tutup aja.
Mbak Erika ada pengumuman? Nggak ada ya Mbak Erika ya? Oke guys, teman-teman semuanya, thank you ya. Thank you.
Nggak tahu, belum kepikiran. Ya paling gitu, kalau mau terus-terusan ya lanjut terus. Tapi kemarin kan beasiswa kan? Oh iya. Tapi beasiswa nggak ada keluar. Ya maksudnya nggak keluar beasiswa.
Oke, thank you semuanya. Selamat siang. I'll see you guys next week. Stay tune ya. Bye-bye. Bye Imran. Thank you so much Imran.
Nah.
Oke. YouTube-nya udah bisa dimatiin kali ya Mbak Erika. Let me try. Oke, bye-bye.